Okay, so today when we're dividing polynomials, we're going to focus on two types, long division and synthetic division. And then we're also going to understand the significance of the factor theorem. Okay, and we are also going to talk about one more theorem called the remainder theorem. So there is a logarithm for division. It is that P of x is equal to d of x times q of x plus r of x. What? Okay, so we're going to write out what those mean. Remember that p of x is just your polynomial. Okay, so p of x is your polynomial, and when you are dividing, it is your dividend, okay, or the value that goes underneath your division symbol. D of x is the divisor. Okay, that's going to go on the outside. Q of x is your quotient, which is what you get when you divide. And then R of x is the remainder. Whenever we divide, we are going to write these in what is called alternate form. And that is just Q of x plus R of x over D of x. So it's your quotient plus the remainder over the divisor. So all of ours are going to be written in this form. Okay, so when you set up long division, okay, underneath is going to be your P of x. Okay, that is your polynomial. You are going to divide it by the divisor, which is on the outside. Okay, and then once you do the division, you're going to end up with your quotient. Okay, you're going to subtract some things. You might drop some things down. And then this is going to be your remainder. Okay, so remember, when you are doing division, okay, which you've done before many, many times, if you're trying to divide something like 3 into 217, okay, you ask yourself, does 3 go into, we'll do 21, right? So it goes in there 7 times. And then what do you write underneath here? Yeah, 21, because 7 times 3 is 21, and then you minus it. You get 0. So, okay, it's not going to go into 0, so you bring down the next number. 3 goes into 7 how many times? Twice. And then you multiply. 2 times 3 is 6. Again, you subtract. And then you have nothing else to bring down, so this is your remainder. We are using these same techniques when we are writing this. Okay, so like this would be 72 and 1/3. Okay, we're going to be using some similar things when we are setting up our long division. Okay, so we're going to divide using long division. And then we're always going to write the answers in alternate form. I put some helpful steps on the side. That's really if you've never done the long division before. I'm also going to show you some other ways you can think about this. So you have 8x cubed minus 3x squared plus 2x minus 1. So that's the polynomial. Okay, that's your P of x. You are dividing it by the divisor. So the x plus 2, that's what goes on the outside. All right, and then there's 2 ways that you can think about this. You can either ask yourself what multiplied by x is going to give you 8x cubed, or you can also just think of this as division. If you do 8x cubed divided by x, what would you get? What's 8x cubed divided by x? 8x squared. Okay, so we're going to put that on the top. Now remember, to get what's underneath, you multiply. So we multiply 8x squared times x The only thing that's different with polynomial multiplication is you are going to have to distribute. So we multiply that by x. We also have to multiply that by 2. So we're going to distribute the 8x squared to x plus 2. So x squared times 2 is going to be 16x squared. Okay, and then once you do that, just like we did before, you're going to subtract. Now, when you see this subtraction, you are going to have to distribute the negative. Okay. Oh, cubed. Yeah, this is cubed. Thank you. Yep. 8x squared times x will be 8x cubed. 8x squared times 2. Yes, thank you. These two should always match. Okay, and when you are subtracting, if you have more than one term, you are going to distribute the negative, and when you distribute a negative, that is what changes the sign. Okay, so when you distribute the negative, you are going to change those signs. So often to show that we have changed the signs, we are going to circle it. So this becomes a negative, this becomes a negative when you do the distribution. If you do this correctly, this should always make 0. You don't have to write that part down. And then negative 3 minus 16 is negative 19x squared. Okay, and then we are going to drop down the 2x, and we are going to drop down the negative 1. And then we get to start our process all over again. Okay, so see if you can fill this in. What times x equals negative 19 squared? Or again, you can just think of it as negative 19 squared divided by x. Why don't you put that answer on top and then distribute? All right, so we should have got negative 19x. That's what we're putting at the top. Okay, so once we distribute, again, these should match. Negative 19x squared, and then a negative times a positive is going to be a negative, so we get negative 38x. Okay, and right now the signs here are the same. Okay, and we are going to distribute the negative again. So when you do that, we just change the sign and circle it. Change the sign and circle it. Because minus a negative is a positive. Minus a negative is a positive. So those should make 0. Here we have 40x minus 1. All right, and then we can just do 40x divided by x, which is 40, or 40 times x equals 40. And this should be positive. So here they should match. And then when you do the opposite, you can just circle that. Okay, so negative 81. This is going to be your remainder. Okay, you know you found your remainder when the degree, so this is not applicable, nothing times x is going to give you negative 81. Okay, so you stop when the degree of the remainder is less than the degree of your divisor. Okay, so sometimes people will ask me, well, how do you know when to stop? Okay, when this degree is less than the degree of the divisor, that's when you can't go anymore. So do you guys remember what the degree is for a constant term? If there's no x, it's 0. Yeah? And then the degree for x plus 2 is, it's linear, so the degree is 1. Okay? All right, so then let's write this in alternate form. So your final answer is going to be your quotient. So your quotient is what is on top, 8x squared minus 19x plus 40. And then because this is negative, you can do minus 81. You can also do plus the negative, that's okay. Okay, and then x plus 2 on the bottom. So this is going to be your solution. And then for part B, one thing I recommend, it's not mandatory, but I really do think it helps make sure you don't combine any terms that are not like terms, is to put in a placeholder. So if you look at this dividend here, this polynomial, you have 6x to the 4th plus 2x cubed minus x plus 2. There's no x squared term, so if you want, you can put in the placeholder of 0x squared, okay, so that when you are multiplying, if you have an x squared term, you can line those up. So this would be 6x to the 4th plus 2x cubed plus 0x squared minus x plus 2, and then x squared minus 2x plus 2. Okay, so last year you didn't have any trinomials that you were dividing. Okay, they were usually binomials that you were dividing in there. So do you guys want to give this one a try? Same process, divide. So again, when you're starting this off, feel free to just do 6x to the 4th divided by x squared. So that would be 6x squared. That's what's going to go on top, and we distribute. So we have 6x to the 4th minus 12x cubed, and then this is where having this placeholder comes in handy, because if it wasn't there, you'd line it up with this, and some people might accidentally combine those together because they're stacked on top of each other, but for this, you don't want to do that. It's only your like terms. Another way we could write this, maybe you remember this from last year, is if you wanted to write the negative in front and put that in parentheses, that also indicates that you're distributing. So this value minus would be 0, 2 minus a negative 12 would be addition, so you'd get 14. 0 minus 12 would be negative 12x squared, and then you would drop these two terms. I prefer the changing signs because I don't like looking back and forth. I just want to add straight down. You can pick what works best for you. Okay, and then the next one we have is the 14x cubed divided by x squared, which will be 14x. Okay, so that goes above. So when you multiply, you should get 14x cubed minus 28x squared plus 28x. And then, like I said, I like to distribute and change. So minus a negative becomes plus. This becomes minus, and now I can go straight down. So 28 minus 12 is going to give you 16x squared. A negative and a negative is going to give you negative 29x. Okay, and then this plus 2 is just going to drop down, and we do the process again. So 16x squared divided by x squared is 16. Okay, so then I get 16x squared minus 32x plus 32, and then I'm going to change those signs. And then once I change, I circle those. So you have 3x, 2 minus 32 is negative 30. This is going to be my remainder. Again, we look at the degrees. The degree for this, it's linear, so it's 1. The degree for this trinomial is 2. So that's how I know when I'm going to stop. So your remainder doesn't have to be just a number. Okay, so we have 6x squared plus 14x plus 16. And then you're going to put the remainder over your divisor. Okay, so this is your q of x plus r of x over d of x here. Okay. Yeah. No. Nope. Other questions on the long division? You do not have to do any factoring at all. All right. So the next thing we're going to look at is the remainder theorem. Okay, and the remainder theorem tells us if p of x is divided by x minus c, then the remainder is p of c. Exactly. So let's talk about what that means. So when they're saying you're dividing by x minus c, that divisor, c is just going to be a constant term here. Okay, and it has to be of this form. Okay, this form, it has a leading coefficient of 1, and the degree is 1. And we're going to write that here. So we're going to be using synthetic division and the remainder theorem to divide. And I put this note here. You can only use synthetic division when the divisor is in this form, x minus c, which means the leading coefficient is equal to 1. So the value in front of x is 1, and the degree is 1, which just means it's a linear factor. Okay, so the leading coefficient is 1, the degree is 1. Now this P of C, this is your output when you plug in okay, if it's asking you to find P of C, you have to plug in what? What would you plug in if they said P of C? You plug in C. Okay, so what that is saying is if you are dividing by the factor x minus c, then your remainder is what you get when you plug c into the polynomial. Okay, so those are going to match. Like your remainder, if you were to plug this in, that should be the same. Okay, and we'll look at that. So I just want to be very clear about what is the form x minus c and what is not. So we're just going to do some very quick examples, okay, of x minus c form and not x minus c form. Okay, x minus c form can include something like x minus 1 or x plus 3. It is not x minus c form if you have 2x minus 1, because why? Why would this not be x minus c form? Right, the leading coefficient is 2, not 1. Okay, or, let's do another one. Or if you had x squared plus 3. Okay, why wouldn't that work? Yeah, your degree is 2, the degree is not 1. Okay? All right, so we are going to use synthetic division and the remainder theorem to divide. Okay, and then again, there is that note that we talked about. You can only use synthetic division when the divisor is in this form, x minus c, leading coefficients 1, degrees 1. We are also going to be writing our solutions in alternate form. When you're doing synthetic division, you are going to use placeholders if there is a missing term, including a constant. Because sometimes people forget about those. Even if it's the last value. Sorry, I'm getting missing terms with like one word. Do some of you remember how to set up the synthetic division? Kind of looks like a, well, it looks like a half of a rectangle. Maybe once we draw that, it'll come back to you. We're going to put some directions here, so does that ring a bell? Okay. So when you are dividing, this is p of x equals, they give you a polynomial, and then it says the divisor is x minus 3. So when you're doing synthetic division, if they give you d of x, you have to set that equal to 0 and solve for x. Okay, which again, that's going to be very simple to do. If you have x minus 3 is equal to 0, then your x is equal to 3. Do you guys remember where that goes in synthetic division? Yeah, there's a little box next to it. I don't always draw the little box. Like that little guy there. Okay, and then we're going to do synthetic division. If you've done this before, I'm confident it will come back to you. If you haven't, we are going to write down the steps. Okay, so the first thing we have to do is we have to write down the coefficients of p of x. So we're going to use the coefficients of p of x. And if you remember how to do that, feel free to write those in. Okay, and then what you do is you drop the first value. Okay, so we're going to do those 2 steps. So the coefficients of p of x, we start with x cubed. The coefficient would be 5. Coefficient of x squared is negative 2. Coefficient of x is 1, because I can't see the number there, and then negative 10. Don't scrunch those together. Please take the space that you need for those, because generally if there's a mistake made, it's because people put them too close together and like thought of this as a 21 instead of a negative 2 and a 1. Okay? Okay, and then so we said drop the first value. So you drop the 5. Do you guys remember what you do with the 5? Yep. So you multiply it by divisor. So you multiply it by 3. Once you multiply it by the divisor, you put the answer in the next column. So 5 times 3 is 15. And then what do you do with these 2 numbers? What do you do with negative 2 and 15? Add them. Add and repeat. Okay, so negative 2 plus 15 is 13. Now I repeat myself. So, bless you. So, when I say repeat, repeat steps 3 and 4. So, 13 times 3 is 39. Add straight down, 40. And we do it again. Okay, 40 times 3 is 120. 120 minus 10 is 110. And then once you get to the last one, I always circle it because this is going to be my remainder. And then I work my way from the remainder so I know what these are. I usually call this the number. It's the same thing as the constant. and then I call this one my x term and this one my x squared. Okay, so when I write this out in alternate form, it's going to be 5x squared plus 13x plus 40 plus 110, and then remember that goes over d of x, the divisor. What's the divisor? X minus 3. So don't put it over 3, you're going to put it over x minus 3. Okay, so you have to put it over the divisor there. Okay, and then for B, I want you to look at that. That was a little bit different. Okay, so before we were given the divisor d of x, now what are we given? Instead of d of x, what are we given? What does it say? Just the constant term, right? Your c. So if that's the case, you can set up your division right away. Okay, negative 5 is going to go here. And then you have 4x squared, but do you notice how you don't have an x term? You have to put in your placeholder. There's 0x and then negative 3. We always drop the first one. Okay, so 4 times negative 5 is negative 20, add straight down. Negative 20 times 5 is 100, add straight down. Okay, so you have your remainder, your number term, your x term. So it's 4x minus 20 plus 97 over, we have to find d of x. They gave us c. Okay, if c equals negative 5, keep in mind that d of x has to be in the form x minus c. So just plug it in. What's x minus negative 5? X plus 5. Okay, are you going to have to do that whole process every time? No, but this is where it comes from, right? If c is negative 5, and we know d of x is x minus c, we just plug in negative 5 for c, minus a negative turns into a plus, so the divisor is x plus 5. That's going to go underneath our remainder. Okay. Did you guys do understand? Oh, okay. Okay. Okay, and then for example 3, it says use synthetic division and the remainder theorem. Okay, so we're using synthetic division and the remainder theorem to evaluate p of 1/2. Okay, so remember we talked about, this is just saying if you divided it by x minus c, the remainder is p of c. Okay, so p of 1/2 is going to be equal to your remainder here. So whenever it says the remainder theorem, we should just be thinking that the remainder is equal to p of c. And then why don't you guys go ahead and set up your synthetic division, and then before you start doing it, we can check that together. Okay, so you have 2x to the 4th. Notice that there is missing an x cubed, so we have to put a 0 in there. Then we have negative 3x squared. We have an x. And then what else are we missing? The constant. So we have to put a 0 in there. All right, and then we're going to drop down the 2. So if it is p of 1/2, this is going to be your value for c. Okay, p of 1/2 means the c value is 1/2. That is what we are going to use in our synthetic division. Okay, so 2 times 1/2 is 1. 0 plus 1 is 1. 1 times 1/2 is 1/2. And this is going to happen where you are going to have to work with fractions without your calculator. I think it's easiest. You should know that negative 3 plus 1/2 is equivalent to 2.5, okay? And once you know that, you can rewrite that as an improper fraction. 2 times 2 plus 1, 5. So this is negative 5/2. That way when you multiply the numerator by the numerator. So this is negative 5 on top. 2 times 2 is 4. And then this works out pretty nicely because 3 minus 5 is over 4 because it's a common denominator. And then we just reduce. Negative 1/2 times negative 1/2, just be careful with that. Make sure you multiply the numerators and the denominators. Okay, and then this is your remainder. Okay, so we just want to remember for this, p of 1/2, that's your p of c, is equal to the remainder. So your answer is p of 1/2 equals negative 1/4. Okay, now if you were to take this 1/2 and plug this in here, you would get the exact same answer. Okay, so if you did 1/2 to the 4th power times 2 minus 3 times 1/2 squared plus 3/4 times 1/2, you would get negative 1/4. Those are the same. But we're using the remainder theorem to show what that's going to be. The other theorem we're going to use is the factor theorem. Okay, so the factor theorem tells us that C is a 0 okay, C is a 0 of P of X if and only if X minus C is a factor of P of X. Okay, so the value of C is a 0 of the polynomial if and only if X minus C is a factor of that polynomial. If X minus C is a factor, okay, whatever your value for C is, if that is a factor, then you should get a remainder of what when you divide? You should get a remainder of 0, because if something is a factor, it goes into it evenly, right? Factors of 12 are 1, 12, 2, 6, 3, 4. Whenever you divide those in, your remainder is 0. Okay, so this says use the factor theorem to show that X minus C is a factor of P of X for the given values. Okay, and then just note that all of your factors need integer coefficients. So integers are positive and negative whole numbers. Okay, so when you're using this factor theorem, you are going to show that the remainder is 0 when you use synthetic division. Okay, so for A, they give you the polynomial and they give you the value of C. I want you to go ahead and do that synthetic division. So if you're using the factor theorem, you're going to show this with synthetic division. Again, spacing is the #1 cause of mistakes in the math test, is synthetic division. Take the space you need. Do they sound like a commercial? Okay, now if you did it correctly, because it says to use the factor theorem to show, you're essentially proving that, verifying that it's true. So once that happens, you're just going to say since r is equal to 0, and then you have to write the factor. So if it's 3, do you guys know how to write the factor x minus c? It would just be what? Yep. So you would say x minus 3 is a factor. Okay, and then you'd have your work for that, and then the x minus 3. All right, and then for part B, you have 2 of them. You have c equals 1/3 and -2. Okay, so we're going to do these separately. So I have 3x to the 4th. I have -1x cubed, -21x squared, -11x, and 6. So I don't have any missing terms. When you're doing synthetic division, it's okay if it's not an integer. It's just the factors have to be integers. Okay, so what is 3 times 1/3? Turns out nice, right? Just 1. Okay, so -1 plus 1 is 0. 0 times anything, 0. This is really -21 divided by 3, so you get -7. That is -18. Okay, and again, really, if there's a mistake made, it's just a small arithmetic error, so just be careful there. Okay, and then when you're writing out the factor, because it cannot be x minus 1/3, because it's not an 1/3 is not an integer, all you have to do is multiply by the denominator. So what's the denominator of our fraction? 3. So if you multiply this by 3, you distribute. Times 3 times 3. So it's 3x minus 1. Okay, and you would say that is a factor because the remainder is 0. Okay, so if you do have a fraction, you just multiply by the denominator, and that will give you integer coefficients here. And then we have to do -2. Now because we're using the same polynomial, I'm going to use the same coefficients. Okay, we always bring down the first. We multiply across, we add straight down. Negative times a negative is a positive. Add, you get -7. Negative times a negative is a positive. 14 minus 11 is 3. Yay. Okay, so because your remainder is 0, if it's a -2, x minus a negative is a plus. So we say x plus 2 is a factor. All right, so your homework for this is page 251.